and thanks for watching the long-awaited recording of Homework 411. This is a wrap-up of logarithms revisited and some unit circle concepts, and there are some other bits of information on here. So here's the key, and rather just put this up here and let y'all copy it, which you may do anyway, but I do want to discuss a little bit of it and how I got these answers. 4-7 asks you to sketch each of the following angles onto a unit circle, then find the coordinates of the angle. Now, some of these you should already have on the unit circle in your folders, but I went ahead and sketched out a unit circle here, and you can see where I sketched out the 45-degree lines, 30-degree, 60-degree, 90-degree, and so on and so forth. Now, I tried to only focus on the ones that I needed for this problem, so I'm looking at 5 pi over 3. So I looked and said, well, 5 pi over 3 is going to be down here. So what are going to be the coordinates of that? Now, remember when we talked about you really only need to find the coordinates in the first quadrant, and then those same coordinates are going to be mimicked. They're just going to be positive in quadrant 1, negative then positive in quadrant 2, negative in quadrant 3, and positive negative in quadrant 4. So I'll look to see. I noticed that the 5/3 coordinates were going to mirror the pi over 3 coordinates. So I used the pi over 3 coordinates of 1/2 and comma root 3 over 2 and use the positive and negative. Same situation for B, except here I'm doing negative 5 pi over 4, which is negative 4 pi over 4 and then one more pi over 4. So going the negative direction to 4 pi over 4 or a whole pi, and then another negative pi over 4 takes me to negative 5 pi over 4. This is a mirror of pi over 4. That it's going to be quadrant 2, so you're going to have negative then positive. So any of your pi over 4s, you're going to have root 2 over 2, comma root 2 over 2, so it's just a matter of the signs. And in quadrant 2, x is negative and y is positive. Feel free to pause, rewatch, rewind, whatever you need to do to grasp this concept. On C, here we're working with 8 pi over 3, and again you can count in thirds, and notice that the thirds are going to have the 1/2 in the x position and the root 3 over 2 in the y position. It's just a matter of the signs. So for 8 pi over 3, I knew that 6 pi over 3 was 2, so that took me back around to my initial starting point. And then another pi over 3 gives me 7 pi over 3. And then one more here takes me to 8 pi over 3, which again is in quadrant 2. In quadrant 2, my x values are negative, my y values are positive. Pause if you need to. Make sure that you have all of this on your sheet. If you have questions about it, then please feel free to come to intervention on Monday, Wednesday, or Friday, and let me help you understand this. Question 4.8 actually is going to kick us into some trigonometric identities. We're not quite there yet, but we're going to use these same concepts there. This is given the equation s squared plus c squared equals 1. Simplify each of the following. Well, switching places with them in addition, it doesn't change the value of it. So, for instance, if you said 4 plus 1 equals 5, 1 plus 4 would also equal 5. So using that same property, switching places of these would still yield an output of 1. Now, on part B, they have 1 minus c squared. So if I started with the original equation, s squared plus c squared equals 1, and then I subtracted c squared from both sides, that would give me 1 minus c squared, and then I would have s squared on the other side. So that simply equals s squared. The exact same concept for part C. On part C, if I start with my original equation and I subtract s squared from both sides, then I have 1 minus s squared on the right, and I end up with c squared as my response for that. So looking at part D, since these are squared and added together, you cannot split them apart and simply say that it's the square root of 1. So this one does not simplify. For E, if I take my 1 minus s squared, which is up here in part C, and multiplied it by 4, I would have to multiply both sides by 4, so I'd simply end up with 4 times c squared. F is a similar situation. If you take problem E, and you distribute the 4 through both parts of the parentheses, you end up with the question for F, so you have the same response there. On 4-9, we're going to do a little bit of conversion here. Okay? This is a wheel is spinning at 500 revolutions per minute. Remember, 1 revolution equals 2 pi. So I started out by saying then 500 revolutions times 2 pi equals 1,000 pi. Okay? So we have 1,000 pi per minute. This is how many radians per second is that giving the exact value. So I have 1,000 radians per minute, and I know that 1 minute equals 60 seconds. So I can cancel out my minutes, and then I have radians per second. So that's 1,000 pi radians divided by 60 seconds, which gives me 500 pi over 3 radians per second. I know it's a little bit messy, which is why you need to make sure that you're listening to this also and not just copying down all the scratch. 4-10 is a little bit of log practice, and a couple of you have asked for more log practice, so please take advantage of this. This is to copy and replace the question mark with the correct number or state impossible and explain why. So here, if we write, well, really each one of these, if we write them in exponential form, then we might more easily be able to see what that question mark is going to be. So writing this in exponential form, 3 to the question mark power equals 9, and of course 3 squared equals 9. So hopefully you won't have a problem with that. Here, 3 to what power equals 1/3? Well, remember that if you have a negative exponent, to make it positive, you flip it. So that's 3 to the negative 1 power. On C, 5 to the 4th power equals 625. D is impossible because no exponent is going to yield a 0 product. E, 5 squared is 25, and F, the square root, or 5 to the 1/2 is the square root of 5. So there's no calculation on that one. Just recognizing that the 1/2 power is the square root. 4-11 says to simplify each of the following expressions into a single reduced fraction. Okay, so remember here that dividing by a fraction is the same thing as multiplying by its reciprocal. So instead of dividing by root 3 over 2, I'm going to multiply by 2 over root 3. When I do that, I can see that my 2's are going to cancel out, and I'm left with 1 over root 3. But you cannot have a square root in the bottom of a fraction. It is illegal, and they will put you in math jail. So we have to rationalize our denominator by multiplying the top and bottom by root 3. So when I multiply across, 1 times root 3 is root 3. And on the bottom, root 3 times root 3 is just 3, so your final answer is root 3 over 3. B is a little bit more complex. Okay, it's a lot more complex. So looking at B here, we have 1 over x minus x times 1 over x plus 1 minus x. So I started out by taking each portion here and finding a common denominator. So finding a common denominator of x here gives me 1 over x minus x squared over x. And finding a common denominator here gives me 1 over x plus 1 minus x plus 1 over x plus 1. So then I simplified from there. Combining my like terms here, or not combining my like terms, but combining my fractions, I have 1 minus x squared over x. And here I have 1 minus x plus 1 over x plus 1. The 1 minus x plus 1, distributing the negative through the parentheses here, will give me negative x over x plus 1, which is where I was here. Now you're multiplying two fractions. I've got 1 minus x squared over x times negative x over x plus 1. So if I factor a negative 1 out of that negative x, then my x's can cancel out. Then if I factor negative 1 through this parentheses, then I get x squared minus 1, which is a difference of squares. And it factors into x minus 1 times x plus 1. That x plus 1 will cancel out with the denominator, and you're left with simply x minus 1. To be fair, this is kind of a complex problem. It would be something that I would put as a bonus on the test. Take that as you will. 4-12. Hey, there's only 3 more problems with many parts per each. 4-12 says, a car travels 45 miles per hour for 3 hours and 55 miles per hour for the next 2 hours. How far did the car travel? So just a little math can help you out with that. But it's going to ask you to graph it anyway and ask for the area under the curve. So go ahead and graph it. We're talking about speed and miles per hour. So this is draw a speed versus time graph. Time, of course, is going to be your x-axis, and your speed is going to be your y-axis. So I put 45 and 55 on here. Those are only pertinent numbers. And I'm going for a total of 5 hours. So I go ahead and mark out 5 hours. I'm moving at 45 miles per hour for the first 3 hours. Then I'm going 55 miles per hour for the next 2 hours for a total of 5 hours. So if I'm multiplying 45 miles per hour times 3 hours, then I end up with 135 miles. And if I'm going 55 miles per hour for 2 hours, I'm going 110 miles. When I add those two together, I get a total of 245 miles, which is representative of the area underneath the curve. So the answers to part A and B are the same. And you can use distance equals rate times time. And that's the same as area equals base times height. So that's why the area under the curve is the same as how far the car traveled. 4-13. It says convert the following angle measures. We did something very similar to this in class recently. So you can use your unit circle for this, or you can simply use a ratio. If we know that there's 180 degrees in pi radians, so then you can set that equal to 48 degrees in x radians and simply cross multiply. When you cross multiply here, you get 180 times x equals 48 times pi. Divide both sides by 180 and just reduce your fraction, and you end up with 4 pi over 15. Same situation on B. Here you are working with 180 over pi setting equal to negative 500 over x. Again, cross multiply, divide, and reduce your fraction. Now, you can change the negative 500 degrees to positive degrees of 220 if you'd like. And I showed both answers for those. So working it the other way, it works basically the same if you're working radians to degrees. But I reduced this a little bit. This wants to change 13 pi over 12 radians to degrees. Well, 12 pi over 12 radians is just pi. We know that's 180 degrees. So we really just need to find out what 1 pi over 12 is in degrees, and then we can add that to 180. Well, if pi over 6 is 30 degrees, then pi over 12 is half of that, or 15 degrees. So 180 plus 15 is 195. Let's look at D. This is negative 20 pi over 9 radians to degrees. So again, I worked in whole numbers and took out negative 18 pi over 9, which is negative 2 pi, or negative 360 degrees. And that left me with negative 2 pi over 9, which is negative 40 degrees. And then I just added them together. Negative 360 and negative 40 is negative 400. One more. 4-14. I want you to rewrite each of the following equations in y equals a times b to the x format. It's basically wanting you to just get an x as your exponent. I'm not sure that this is something that I would ever test you on, so I'm going to leave this up here so you guys can pause it and get that down on your paper so that I know that you worked through the video and did all of your homework. And we can discuss this in class if you'd like or during intervention, but again, this is not something that I would test you on.